How do you draw Lewis structures? In a compound such as carbon dioxide or CO2, you first need to centralize the least electronegative element. Remember that electronegativity increases as you go up the periodic table and as you go right. So carbon will be less electronegative, meaning it will be in the center. And we will place 2 oxygens outside. The next thing is to count the number of valence electrons that we're going to have. Carbon will have 4 valence electrons, and each of the oxygens will have 6. So if you add 4 to 2 times 6, you will get 16. Now that we know how many electrons we have, we will use that to find the Lewis structure. So the first thing we want to do is single bond the carbon to both of the oxygens. Each of those bonds represents 2 electrons being shared, meaning that we've spent 4 electrons. Now, we're going to draw valence electrons, or lone pairs, around the most electronegative atoms first, until we run out. The reason why that we only draw 6 on each of the oxygens is because there's something called the octet rule, meaning that each atom must have 8 electrons, where a bond counts as 2, so the oxygens already have 2, and then they need 6 more to become octeted. Note that hydrogen and helium only need 2. So even though it's still called the octet rule, it's only a duet for hydrogen and helium. Now that we've drawn the structure, we still have to do some adjustments to get to the correct structure. Well, the first thing is carbon is not octeted, meaning that this cannot be our final Lewis structure. We're going to want to first take 2 electrons from one of the oxygens and share it with the carbon. We have maintained the correct amount of electrons, only using 16 in total, 6 in the bonds and 10 as lone pairs. But now, carbon has 6 electrons instead of 4, and oxygen maintains its 8 electrons. Now we can do that again with the other oxygen to reach 8 electrons for the middle carbon. And this is our Lewis structure. Let's take a look at another problem. Draw the Lewis structure for NO3H. So again, we're going to center the least electronegative atom, and we're going to place the most electronegative atoms outside. And we're just going to tag the hydrogen onto any side. Now let's count the valence electrons. And we get 24 valence electrons. So let's start off by putting in the single bonds. And now we have to subtract 8 electrons. And we have 16 electrons to place. So now that we've placed our 16 electrons, we have not octeted the middle nitrogen, meaning that we need to share 2 electrons from one of the oxygens in order to do so. Now, how do we choose which oxygen to do this? Well, let's look at something called formal charges. This is when you take the number of valence electrons that an atom normally has and subtract the number of electrons that it has in our Lewis structure. The difference between how we count bonds in how many electrons total and how many bonds in formal charge is that each bond only counts once for each element that is on either side of the bond. So this oxygen on the left here, oxygen normally has 6 valence electrons. So we're going to take 6, subtract 7, and we get -1. That's going to be this oxygen's formal charge. Now this other oxygen here has 4 electrons as lone pairs and 2 that are bonded. So that's 6. So 6 minus 6 equals 0. So this is a formal charge of 0. You want to have formal charges as close to 0, but if they're not all 0, you want the negative charges to be on the most electronegative element. So we're not going to disturb the 0 in this oxygen, but rather we're going to take an electron from one of the already negatively charged oxygens and share it with nitrogen. And there we have it, the Lewis structure for NO3H. Let's look at one more problem. Draw the Lewis structure for sulfate, or SO4 2-. So sulfur is the least electronegative, so we're going to center it and place the oxygens outside. Now the electron count is 6 plus 4 times 6, and we add 2. Because it is 2 minus, meaning that we'll add 2. And we get 32. So let's start off by connecting the single bonds, where we use 2, 4, 6, 8. And then we have 24 remaining. Now, we could just tag 6 on each of the oxygen atoms, and that would be 24. However, that would leave all the oxygens with formal charges of -1. because it would be 6 minus, they would have 7 because 6 around. So for example, if we were to put 6 on all the oxygens, then we would have 6 and then 1 from the bond minus 7, and we would have -1. But we can do better than that. Elements that are in the period 3 or row 3 of the periodic table and beyond can do something called being hypervalent, meaning they can go past having only 8 electrons. So we can actually double bond 2 of the oxygens in order to lower their formal charge to 0, and additionally to raise sulfur's formal charge to 0, because sulfur with 6 valence electrons minus the 6 bonded electrons equals 0. So sulfur is 0, and if we add in all the electrons, we have 0 for this oxygen, 0 for this oxygen, -1 for this lower oxygen, and -1 for this other oxygen. And so the formal charge is optimized because although we do not have all zeros, the negative charge are on the most electronegative element. And we've used the correct number of electrons to draw the Lewis structure for this compound. Thanks for watching. Like and subscribe.